notation? Natural language, structured natural language, graphical notation, and formal method. So those who are taking formal method now, there's a course you have to take, formal specification, formal method. So those who are taking formal method now, somehow you can answer the question with some of your, based on your experience maybe. But those who are not taking formal method this semester, I'm very sure you got no idea what is formal method. So that's why it is important for you to be here. Okay, great. So I always have a question on formal method. I can promise you that. Okay. So the first hint, there is a question on formal method. Okay. Whatever I'm going to cover today. Okay, I stop at what diagrammatic notation. Let me check where. Okay, all the diagrammatic notation done. Okay, so this is another diagram. Of course, what do you call that? I got go through this in the previous lesson also. So this is called R-NAT. Okay, so you can use logical operators such as or, and, combine different. Okay, what do you call that? Conditions or requirements. Okay, to flow the system. Okay, or to show the output. So this is another diagram. Also comes under diagrammatic approach. Okay, what else? Integrating multiple system views. Yeah, this one I could mention last class. What is interview consistency? What is intra-view consistency? Let me recall again. Okay, intra. What's the difference? Interview, one is inter, I-N-T-E-R. The other one is I-N-T-R-A. What's the difference? Intra means within the same diagram, just within one diagram or more than one diagram. Intra. Yeah, the same diagram. Intra means one diagram. So within one diagram, what kind of consistency can you show? Who can tell me? Within one diagram, what kind of consistency check can you do? Okay, let's look at this one. So here we are looking at inter, right? Where's intra? Yeah, you see intra. So this is inter, there's no intra. Okay, never mind. So let me cover both in this one slide. Okay, what is intra? Intra-view consistency. Meaning within one same diagram, what kind of consistency you can check? Anyone? When you are drawing, okay, let's say use case diagram. What kind of consistency can you apply within one diagram? Intra-consistency. Intra-view consistency. Within the same diagram. Yeah, like notations. When you draw the actor, right, you follow the same actor symbol. Because actor symbol got two, right? You can either draw the actor, what do you call that, like the man shape, and the other one is rectangle shape. So within the same diagram, why you want to show different design? Okay, so try to apply consistency. Okay, the font size, for example, the format especially. Try to be consistent. So this is within the same diagram. Rarely come out intra-consistency. Inter-consistency is very popular. Inter-consistency means among your diagrams, any 2 or 3 diagrams must be consistent. So because for the same project one. So the diagrams must be consistent with each other. That is inter-view consistency. So I can ask you one. Okay, then let's see whether you can answer one. Okay, what kind of consistency can you apply between use case diagram and sequence diagram? Use case you learned earlier, sequence diagram you just learned in the previous class. So what kind of consistency you can apply when you are drawing use case and sequence diagram for the same project? Can anyone tell me? Yeah, what kind of consistency can you show when you are drawing use case diagram and you are drawing use case diagram and sequence diagram? What kind of consistency you can show in both diagrams? Consistent means tally. Use the same. Okay? inconsistency. Or if you really don't see the relationship between use case and sequence diagram, what about class diagram and sequence diagram? What kind of consistency? I don't mind any diagram. Yes, objects. Okay, whatever objects you have in your class diagram, okay, must be consistent with your use case, your sequence diagram. Let's say sequence diagram got A, object B, object C. But in your class diagram, there is no such object C. Let's say no object C. But in your sequence diagram, I can see A, B, C, three objects. In your class diagram, I can see A, I can see B, but I don't see C. Okay or not? Can be same project. Can or not? Possible or not? Not consistent. If you have in your class diagram object A and B only, no way for you to have object A, B, C. C is not shown in the class diagram. So how can you have one new object in your in your sequence diagram? So that is known as interconsistency. Interconsistency. Okay, what about use case diagram and sequence diagram? Who can tell me? Yeah, I always get this problem in assignment, students, no, they don't know. They make mistake, careless. Okay, can you give me one example for use case and sequence diagram consistency? Function name, okay, good. The function you wrote, let's say, receive feedback. You are drawing sequence diagram for getting feedback. Then I go and search in the use case diagram which is related to feedback. I don't see getting feedback in the use case, meaning no such function. Maybe the phrase you use is different. Wrong. Must be tally. Another very good example, let's say you use the word, how can I say? Okay, admin staff. You call admin staff. Okay? And then the other, part of the diagram, you use the word clerk. Okay? So when I check, in your actor that perform send feedback, process feedback, okay, or response to feedback, okay, is admin staff. But then in your in your sequence diagram, response to the feedback is clerk. Up there, who perform the function? Admin staff. Down there, different. In another diagram, you are putting different role, which is clerk. Not consistent. You understand or not? So this kind of inconsistency we call, interview inconsistency. Interview inconsistency. Got come out in final exam before. Okay? Interview consistency. Explain with example of diagrams. So you need to know how to explain. Meaning, within the same project, whoever actor you introduce, whatever functions you introduce, whatever objects you introduce, must be consistent throughout the diagrams. In one diagram different from the other diagram, but referring to the same thing, inconsistent. Okay? Okay, now, okay, so that's I think the last part. Okay? After this formal method. Yeah, okay? So I got go through the graphical notation, advantages and disadvantages, right, the other day. Okay, important aspects, overview and structuring important aspect. Can show clearly all the important aspects. But of course, you cannot show everything with graphic. Okay, natural language, any requirement can be written. Any requirement, even UI requirement can be written using natural language. But with graphics, you can only show certain things like functional requirement. Okay, even non-functional requirement can show in graphic or not. Is there any diagram to show non-functional requirement? No, or not? You got left any diagram to draw non-functional requirement? No, right? That's why the main drawback is graphical notation cannot cover everything, but natural language can cover everything. Okay? So here, overview, structuring of important aspect, as I said, easy to understand. If I show you a diagram, then I show you text. Both also explaining the same process. Which one you can absorb faster? Obviously, diagram. So easy to understand. Surface level analysis, yeah. All the diagrams you only can show surface level, level 1. Most probably level 1 or level 2. You cannot go detail and detail because the diagram will become very messy. So we don't go level 3, level 4, it's going to be very complicated. So usually diagrams level 1, level 2 maximum. We don't go so detailed even though it is possible in there. Okay? Then what about the drawback? Okay? Language semantics may be not what do you call that? Vague means like not like ambiguous. Okay? Different interpretation. No clarity. Okay? So different notation, different meaning. Sometimes you see the same diagram when you use different tool, different notation and different meaning. Then you are not sure which diagram or which tool is correct. So that's why when you come to assignment or whatever, as tutor, we always determine what tool to use. So everyone learns the same thing using the same tool, come up with the same notation. Okay, in exam also, you know, right? Like ERD, we always use cross-code notation. Okay, for use case, we always use visual paradigm or IBM RSA. These are the tools we always use in our campus. Okay, so that's the reason. Only surface level, as I said, not everything. Limited forms of analysis because cannot analyze every aspect of the system. Only the functional part, especially. Okay. So as I say, functional and structural aspect only. So this two same point, limited to functional and structural only. Functional and structural. UI cannot. Non-functional quality cannot. Other aspects cannot. Because no graphics, graphical notation for all those things. Okay. So these are the drawbacks. Okay. Since for the diagrams, I ask you to draw the diagram, apply, analyze. So I don't really ask you to. But sometimes, you know, to fulfill the requirement, I ask like 1 or 2 advanced pages, you know, to cover up some theory. Because every exam paper we need to cover all levels of question. Low levels are usually theory, understanding and memorize. Knowledge and understanding. Knowledge is the lowest level, memorize. Understanding is like explain, able to explain on. Then third level, fourth level, the one you are doing, all the drawings, analysis, justify. Okay, then we have level 5, level 6. 5 is actually evaluation. You are able to evaluate which one is good, which one is bad, and you are able to give me the reason, justification. That is level 5. Level 6, come up with your own product, or come up with synthesis, meaning produce something all by yourself. So like create new application, write a piece of code all by yourself. That will be under level 6, the highest. For degree, we go up to level 5. Okay, so the focus is level 4. Okay, level 3, level 4. So that's why I rarely ask about all this definition or questions that require memorization. I rarely ask. Okay, so last part. Okay, for the 4 types of notation. Today we are going to look at the last part. Again, you are going to take a course called formal method. Formal method is actually writing the same requirement as I asked you to do now, the project, but you don't use graphic. You will be using mathematics. You are going to use mathematics to write requirement of a project. So what happened usually, Puan Azur will be teaching this course. Okay, like this course under me, right? So sometimes not enough resources will change. But most of the time, Puan Azur will teach Puan Azura. So what happened? She will ask you to use can use back the same title as mine. So if you have taken SRE, you can use back the same title as SRE to do your formal specification because you are already aware of the requirement. You just need to come up with the requirement in the form of formal method, mathematics. So you can save a lot of time. Okay? So if your title is good enough for my SRE, you can use back. If you don't get a good marks because your title is not good enough, not easy to analyze, better change. For formal specification, propose a new title. If the title is good enough, use back. Okay? So they are like continuous. You're going to do the same document, but you're going to use different notation, mathematics. Okay? Okay, now start up. Okay, formal specification got 2. One is model based, the other one is algebraic. Okay, algebraic based. Both also max. Okay, I will be showing some examples. Okay, so there are few languages that you can use for both. Okay, so here in our campus for formal specification, those who are taking, which one are you actually using to do your assignment? Model based or algebraic? Those who are taking formal method, are you using model based or algebraic? Don't tell me you are not sure. This is week 6, almost done with the assignment, right? So you are taking model based or you are using algebraic? Which one? Not sure. Which one? Model based. You draw the state schema, remember? Everything in the form of model, right? Model based. Okay, model based. And the language that you are using is Z schema, correct or not? Z. Okay? So it is model based. Okay? So either one will do, they are almost the same. Okay, so what is all about formal specification? Okay, so let's look at this. It has not become the mainstream software development technique. Yeah. Have you gone to any company that use mathematics to write the requirement? Yes or no? Very rare, but there are some companies, they have to go for formal specification. I will tell you why. Okay, they cannot escape from this. They have to, some companies. But overall, very few. You know why? It is very, very time consuming, very, very costly, very expensive. Okay, and you want to find the skill with the people with the skill, formal specification skill. You cannot find anyone. Most of the local universities, they don't cover this. Okay, they don't have such their course. Okay, so that's why it is quite difficult to find the skill. Very rarely people have this skill. Okay, so let me tell you when to use formal specification. Okay, the main reason for formal specification, main area of applicability is actually critical system. Who can define critical system? Anyone's assignment title here for formal specification, critical system? By right, you only use formal specification for critical system. Otherwise, no point. You are wasting money. For normal mobile application, web-based project, you can just use graphical notation, natural language, structured natural language. You can complete in very quick time. But why are you spending so much of money doing formal specification for mobile application or normal web-based project? Not worth. But I'm very sure most of your titles are mobile application and formal, web-based. Correct or not? You can't avoid. It's okay. Our assignment will allow you to go for that. But in reality, right, who can tell me what is the meaning of critical system? What is the meaning of critical system? Okay, ATM, critical system or not? Yes. What about, cafe food ordering system? Okay, flight control system. Diabetic, monitoring system. Not bad. So, you more or less understand what is critical. Can you define? For those who are coming, who are here, who all the way came for my class today, I told you, right, when I entered only about not even 20 students. So I promised them I will give you a tips today. Final exam tips for those who are here. Okay? So I'm getting into the tips now. So tell me, what is critical system? Sorry? For today. But all involved, no right? Oh, all. If you're not in volleyball also you have to go. Yeah. Many is in your class. But you see, I sent you them. They are still here. Okay, that's why the tips is now, don't worry. Because it's related to the topic I covered today. Okay, now tell me, what is critical system? So, mathematical notation or formal specification very suitable to be used for critical system. So, what is critical system? When the system error or system something goes wrong or system failure can affect the human being, the user, can harm the user or can harm the environment, then it is a critical system. website, if got error, when you submit the form, you enter the wrong email address. So pop up error message. Does it hurt your finger? Does it give you heart attack? Nothing, right? So it's not a critical system. Mobile application also mostly not critical system. Like flight controlling, a small error, the whole flight can crash, accident, can kill hundreds of lives. Critical system. Diabetic patient, something wrong with the measurement or the sensor, or IoT based project like detect pollution level, something wrong with the sensor. What happened? The whole area will be affected with the health issues. Correct or not? So all these are critical system. Can harm the environment, can harm the user. When something goes wrong, is critical system. So usually formal specification is meant for this kind of system, not for normal system. If normal system, you go and use formal specification, no problem. Just that you're going to not make any profit. It will be very, very costly. You understand or not? Okay, why critical system we use formal specification? Okay, this slide very important. So that's why I'm spending time and explaining. Okay, so usually when you use mathematical notation, right? Mathematics, at the end you will get one answer. The working can be anything, but at the end your answer must be only one value. Can go wrong or not? Can go wrong or not? Same thing come to mathematical notation in requirement. You won't get much error. The error number will be very, very minimum. I can say minimum. Very low. Okay, will be minimum. So that's the reason we use formal specification for critical system. It can reduce the error to the minimum. Compared to your natural language, can be ambiguous, can be amalgamation, can cause over flexibility, can cause confusion. Graphical notation, like I say, cannot cover everything. But when it comes to mathematical notation, okay, it can reduce the error, can minimize the error. So what happens? This kind of very dangerous critical system, very important. You must make sure your requirement got no error. Okay, minimum error. So that's why we go for formal specification. That's why they come up with something called mathematical notation. Okay, then formal specification are expressed in mathematical notation, precisely defined vocab, syntax, semantics. So precise, very accurate. No like 2 or 3 options, one final option. So that's the reason. This slide is important, first tips for today. Okay, final exam. This slide is important. Okay, next. Okay, who can explain this diagram? It shows very clearly what formal specification compared to other notation. Mathematical notation compared to other notation. So, you see, specification, okay, with formal specification become like that. If you use natural language or graphics, here, if you use natural language or graphics, you can reduce the cost. You can reduce the cost during the specification. You know, when you use graphic, you can just use any diagram that you any tool that you subscribe and draw the graphics, and all the IT graduate quite knowledgeable in graphical notation or natural language. So very easily can be done the specification, correct or not? So you can just spend very little to complete your specification when you are using other notation. Other notation means natural language or graphics. Okay. Then what happened to the design? Design and implementation, the cost increases. Okay. Then the validation, the cost even increase. Why? Even increase more. Why? Why this two happen? Who can tell me? Because during the design, okay, during the testing, if anything goes wrong, an error is detected, and the error caused by design or the error caused by coding, do you think easy to fix it? The debugging will be costing a lot. Okay, you have to go through the whole cycle again. So that will be cost, of course, time consuming. So your cost will increase so much during the design and implementation, and of course the validation even worse, because testing, even you detect error, 1 error or 2 error, you have to redo the whole cycle again, go through everything again. So the cost will increase. But now, if you use my formal specification, this today's topic, okay, to do your specification, it's going to be time consuming, it's going to be costly method to do the specification, to come up with the requirements. But later on, your design, you can reduce the cost because specification can be like 99% no error. Can ensure the requirements are accurate, precise. So what happened? During the validation also you got no much work to do, no much rework. You don't have to do rework. You don't have to go back because no much error or many errors detected. You understand now? So you can reduce the cost during the implementation and testing. Validation is testing. Clear? Understand? So that's the reason I say you spend now, then you don't have to spend in future. Okay, during the implementation and testing. If you don't want to spend now, then of course you have to spend at the end. Okay, so this other notation. This one is formal method specification. Okay, or mathematical specification. Okay, now there are two types. One is algebraic, the other one is model based. What's the difference? Okay, this one described in terms of operations and relationship. You will show the algebraic. You know what is algebraic, right? Under the topic algebraic, what do you learn in mathematics? All kind of equations, right? Solve unknown and all that comes under algebraic, right? Same thing. Here also, it's all about operations and relationship. Relationship is equation. Okay, so your requirement will be in the form of operations and relationship. Okay, but if you take model-based approach, the system is specified in terms of state models. Okay, state models. I will show you what is state model. Okay, that is constructed using mathematical constructs such as set and sequences. You will use set, functions, relations. Okay, that's what I mean by sequence. So you use sets, functions, relations, this kind of topic from mathematics. You use these topics to write your requirement. So that's the difference. Here you use sets, what do you call that? Sets and functions mainly. There, more to algebraic equations. These are the difference. Okay? Okay. Both also equally good. Okay? Okay. These are the examples. Okay, for algebraic, you need to know a few examples. Of course, I don't ask you to memorize. I don't ask example in exam. Model based, Z, V, BTN, a lot of examples. This one are model based. And you know what? Our UMT has a course called formal method. Need to be taken by software engineering student. We use this Z schema, Z. This one. Okay? Z is under sequential, the other one is concurrent. So these are the languages, same like programming language. So this is mathematical language. Okay? Okay, what else? Okay, now let's look at the algebraic specification first. Okay? So specification of this interface allows for their independent development. Okay, so you have abstract data types, sorts, and objects. So the abstract data types we call sorts. You need to memorize because if I ask formal method, of course I'm going to ask you what questions are which are general. I don't touch any type of formal method specifically. So you need to know as general. Okay. So interface are often defined as abstract data types, sorts. So the interface in algebraic specification known as sorts. Okay, or objects. Okay, the algebraic approach well suited to specification of interface. So you see, you can even specify interface which you can't do in the graphical notation. Okay? Okay, so here is an example. Okay? So you want to integrate this to this, integrate this to this, integrate this to this. For example, this is the subsystem, these are the functions. These are the subsystem, these are the two subsystems and these are the modules. So how can you integrate? So the interface integration. You can explain this using mathematical notation which is algebraic. You understand what I mean? Okay, let's go further. This is how algebraic specification look like. Algebraic specification look like. Sort is like object. The object name, import whatever library you want. Just like in Java, you import a string, you import a string. Whatever you want, you just import, right? Same. You import the library or the specification name that you're going to list of specification you want to import. Then you have your description over here. Then you have all the signature, operation signature. Okay, what is operation signature? Setting out the names and types. So introduction of like data type declaration. You know how you declare data types? How you declare variables using data types in programming? Same thing. That's what we call operation signature. Okay, you are declaring and initialize. Okay, you can do it here. Okay, then exit. You have defining the operations over the sort. Now you can set the initial value, assignment, initialization and assignment can be done here. So first declaration, then initialization, assignment, all can be done at the last part. So these are the structure, okay, of algebra. Okay, let's continue. So introduction, description. So I have gone through all this just now. So again, just summarize again. So this is define the sort of object, creating if what you call that sort of object. Description, just describe briefly what kind of sort of object are they. And then signature, define the syntax of the operation. In syntax here is the data type. Okay, what data type or what kind of object it is. Then here you can actually define the operations. So you can actually show the operations over here. Okay, so usually operation is like in the form of assignment, equal, whatever. Like for example, you set the initial value, the capacity of the hall when event booking. You are booking or registering for an event. What is the capacity of my hall? Let's say 600 pax. So I can, let's say I say the booking can be taking place until the booking number of booking reach the maximum capacity, which is 600. So I have to make sure the operation where I add one, then every time there is a booking, new booking, less than or equals to 600. As long as it is less than 600, that operation can take place. That is an example. Clear? Okay, but don't worry. I will focus more on what do you call that, model base. Okay, so they are almost the same. Okay. Okay, so type of operations. You know what is constructor? You know what is inspection? What is constructor? Default, initial value. Okay, so when you create an object, always, okay, when you create a class, for example, an object, there will be a constructor for default, setting default value. What is the inspection? Validation. Okay, we can put all the validation under inspection. Same like programming. The concept is the same as programming. Okay, so you can go through this one. Okay, this is a simple example of algebra. Who can read this? Who can who able to understand this? Creating list. Creating a list. Okay, imports integer. Okay, so it's a list. You are creating a list. Okay, so this is a description. The list is actually elements are added at the end and removed from the front. At the end, remove from the front list. Okay, so yeah, just explanation. Signature, declaration. You see, declaration we don't do like INTA integer, float, currency or whatever. We don't do that way. Okay. Here we use the function because I told you right. This is mathematical notation. So create is actually a form of list. Okay. So this is a function which contains list element. Okay. It's also a type of list. So this is head list, also an element. Okay. Head is an element of the list. Head is an element of the list. The first element is head. The last element is tail. So this is how you do. The length is the size of the list. Size of the list must be size of an array. Length of an array. Integer, right? Declaration. Integer. But you don't use the word array here because it's not programming. This is mathematical notation. As I said, you'll be using sequence. You'll be using functions. What do you call that? Algebraic. Okay? So slightly different. Okay? Then now comes all your signature done. So now comes all your syntax. Okay? So here head create undefined. As I told you, the initial value setting, assignment, all the conditions can be placed here. All the conditions. Okay, I can show you one. For example, head. Okay, if else create, then we else head is already exists. Okay, if head is not there, create one. Otherwise, if the list is a new list, create the head. If the list is already exists, the head is already there. So that's the meaning here. Okay, length of the crate is 0. So when you start, there is no element in the list. So length is 0. Okay. So can you understand slide here? Of course, you need to learn all the symbols, all the syntax in order to understand completely. Okay. So more or less you know what is algebraic. Okay, notation. Can or not? Okay. But don't worry, your formal specification we use another one. So we have more slides on that. So we focus on that. This is just an example for you to see the difference. Okay. Okay, so done. Construct all this I have covered. So now model waves. Okay, so we're going to use the Z as an example to explain the model waves. So those who are taking formal method, I guess most of the basic info you already know. Okay. Okay. The basic building blocks of Z waves specification are known as schema. We call it a schema. Okay. Every model is a schema. Every model is a schema. You draw a model. Model means like a shape. Okay. Then schema identify the state variables, define constraints and operations. So very easy. First you will have the declaration. Then you will have all the operations. So as you can see here, you have the declaration. Maybe you can have some constraints. And last part, very important part, all the operation. Every operation you will draw one model. Every single operation you need to come up with one model to show the operation. So first, before you can start with the operation, explaining the operation for your project, you need to come up with a declaration list. That is known as state schema. I'll show you one more. Okay, so this is the name of the schema. So again, another word for the schema is model. Another word is container. Okay, so this is the name of the schema. This is signature. What is signature? Who can tell me what is signature? All the declaration. All the declaration. This is all the condition. Okay, constraints and conditions. We call it as predicate. Okay, name, signature, predicate. So this is known as a model, one model, or a schema. Okay, so container, the name of the container. Then this is the declaration. What are the variables you're going to use throughout the operation? You have to declare over here. Then all the conditions. Okay, all the conditions can be constraint. Where do you get the condition from? Constraint. Okay, let me show you. Okay, a simple one. This is a simple one which I'm going to show the example of the schema later. Okay, this is insulin pump. Okay, what is insulin? Do you know what is insulin? 2 minutes to go through this slide. 2 minutes, try to understand this. Then I will go quickly. Anyone here diabetic? Sometimes diabetic not due to food habit, but also genetic. But you guys usually don't take so much of sugar, right? So cannot be due to food. Sometimes genetic. Okay. So this one, who can explain this more? What do you call that? How it works? How this pump works? The flow. Yeah, the flow. Who can explain? First, you know what is insulin? Let me tell you what is insulin. Everyone has certain glucose level. Glucose level low means not good. Very dangerous. Your body got no energy. Your body got no glucose supply means even oxygen is there also no point. You can it can cause death. So it's not good. When I was pregnant, I remember I always got no time to take breakfast. My glucose level was very low. I about to faint. So the doctor immediately gave me two bottles of dripping. Was telling the baby can die on the spot. You shouldn't have low glucose. Usually people have high glucose during pregnancy. So glucose is very important. You have to maintain the level. So now, if the level is too high due to genetic or food intake, you have to control. How to control? You need to intake one hormone, right? Insulin. Okay, you need to take insulin to control the glucose level. So, you see, this is the insulin pump. Okay, this is like automated. You implant in your body. It will detect your glucose level measure your glucose level every 1 hour, every 2 hours, depends on different
type device different. Okay, detect from time to time, like checking. Instead of going clinic, okay, seeing doctor to check every time or nurse to check. Like, you know, old people, they got no one to take care, so people buy this kind of device, implant in their parents' body. So it will monitor, self-monitoring. Okay, so what happened when the glucose level, you see what happened here. The pump is there, the controller, you see the controller? Every certain time it will check, the sensor will check the glucose level. If the glucose level suddenly goes high, okay, the sensor will be detecting. Sensor always to detect something. So this sensor is to detect the glucose level. Once detect the glucose level is high, it will, okay, alarm, play the alarm to notify your glucose level is high, to let the patient know. Okay, number 2. Okay, it will show the value on the screen, your dose delivered and the text message, of course the display. Since the sensor detected the glucose level is high, the controller one will play the alarm. Okay, and the second thing, the controller will ask the pump, will instruct the pump, okay, to induce insulin. Induce means release insulin to the blood, into the blood. So what happened? When the glucose level high detected, it will, controller will instruct the pump, okay, to release insulin through the needle. So that's the basic flow. You can understand? A simple application, but is this critical? Yes. If you don't, let's say the sensor spoiled, what happened? Or let's say the controller got error. Okay, reading error. What happened? Can kill the patient, you know. Can kill the patient. So this is a critical system. This is what I mean by critical system. Okay, can you understand? By right, for formal method, you guys need to propose title like this. Anyone propose title like this? I don't think so. When I was teaching also, always the title will be web-based or mobile application. But we all okay with that, because we cannot demand so much, short answer. Okay, so this is critical system. Okay, so this one is small error, a very minor error can kill the life, right? So that's why you need to use mathematical notation for this. Okay, so now look at the requirements. Okay, what is this? Who can tell me? Reading. So you have the definition, data dictionary. Do you know what is data dictionary? Same use, same. Okay. So reading, what is reading? From glucose level sensor. Dose, cumulative dose. This dose is every time when I induce the insulin, what is the dose? For the whole day, how much of dose have been given? Cumulative. Like until the end of the day, you can show the cumulative because there is maximum value to be delivered in one day. Okay? So R1 is reading 0, reading 1, reading 2, reading 1, reading 2, reading 3. 3 readings. Okay? Then capacity, insulin pump reservoir level. How much of insulin have been stored in the pump? Okay? Alarm signal for exception control. When suddenly glucose go high, it will notify the patient. Pump, okay? Output for insulin, where the insulin will be released. Okay, display 1, display 2 on the screen, display message. Okay, output. Okay, so let's look at the next one. Okay, this is called state schema. Okay, those who are taking formal method, what is state schema? We got a few types of schema, right? Every every project, you should start with state schema. You know state schema? Wrong. You should start with state schema. Then only you can go for operation schema. So what is state schema? What is state schema? Yeah, I know who are taking formal method. So what is state schema? State schema, group 2. So how was Japan? Okay, so back from holiday. So try to recall what is state schema. Sorry? Declare, exactly. You need to declare a variable in order to use in the operation, correct or not? So this is declaration. Can you see what is n? I give you some example. No need to know very detailed. Okay, the switch. What are the possible values? These are the possible values. This like list of values that you can assign to switch. So switch question mark means all the possible value. Switch can be off, switch can be manual, switch can be auto. Okay. Then the reading is natural number. You know what is natural number? The reading data type is natural number. Of course, not like programming, integer, float, double, string, character, boolean. This is slightly different. So this is natural number. Hardware test. These are the values. These are the conditions. These are the values can be hardware test. Okay. So the hardware test can return okay, can return battery low, can return pump fail, sensor fail, or delivery fail. Okay. Then the insulin reservoir can have these two values. Needle, these are the possible values, and the clock is data type. If you see question mark, okay, either I give you the data type or I give you the possible value options, possible options. Can you understand? So if you see like one letter like this is data type. This is data type. Natural number. Time, data type. Time. The others are value. Possible options. Possible options. Can you understand? Okay, then alarm not equals to on and off. Okay. This output device definition. Okay. So display not, okay, same. Continue, just continuing. Just that this is input, this is output. The same thing. Output and input. Input first, then comes output. So this is only on or off. The alarm can be either on or off. Cannot have any other option, any other value. Display must be a string data type. Display 2 must be a string. Clock must be a time. Those must be natural number. Clear? Okay, what about this one? State variables used for those computation. So all the variables that you're going to use in your operation data. Look very simple, right? Just now the insulin pump. Look, very simple system, right? You see the requirement and it's so complicated. Okay? So now tell me, these are the declaration. So capacity is one of the variable. Okay? Insulin available. Max daily dose. This variable to calculate the cumulative dose. In one day, how much of dose you can stop. Okay? Then safe meaning safe max. Home dose, cumulative dose. So all these are variables, declaration. These variables you're going to use later for operation. Operation means process. Process. Functions. Okay? Understand? Okay, class. Very important. So tip for those who came for class today. You will have one question on formal method every year. One question on formal method. You need to clearly understand why use formal method compared to other notation. Why need to use formal specification compared to other type of notation. Very important. One of the questions with the highest number of marks in my question paper always formal method. Okay? Because you will be somehow taking this course this semester or next semester. So that's why I purposely try to include one question on this. Okay? Okay, so next. Okay, now predicate. What is predicate? Conditions. Define conditions that's always true. All the conditions that you need to check, like validations or conditions in your system that need to be checked. Need to be checked before you perform the operation. So comes your predicate now. Okay? So let's look at some predicate. Okay, the dose must be less than or equal to capacity. Yeah, let's say your pump capacity is very little. So is there any possibility for you to have the dose more than the capacity? Not logic, right? So that's one of the constraint. I can say constraint or I can say condition. That's why I say condition or constraint. So you have to define all the conditions of constraint which your operation need to be following later. Okay? So all the conditions of constraint comes under predicate. Okay? Another example. No single dose may be more than 4 units of insulin. Every time maximum dose for any patient 4 units. So one patient cannot receive more than 4 units in one use. No way. Okay? The total dose delivered in a time period must not exist. Maximum dose one person can receive. This is all medical condition. Of course, we don't know. When we develop such system, right? Okay, we have to refer to doctors or medical experts to come up with all this requirement. So when you are working in different domain, you need to have the domain knowledge. Correct or not? We got discussed last time, right? So medical domain, we need medical expertise. Okay. Okay. So these are the examples. Okay. Okay. Now come to the definition, conditions that you need to obey, you need to follow when you perform the operation. So you come out with all the conditions, all the conditions that always must be true when you perform the operation. If any of your operation clash with this, meaning your operation is wrong. You shouldn't have that operation. Any of your operation cannot obey, cannot follow this, then your operation is wrong. Cannot. So these are the rules you need to follow. So that is known as predicate. Okay. So now schema, predicate. Just now state schema, right? Now predicate. So sorry, the dose less than insulin available. So the dose that you are giving to the patient in use must be always less than the available insulin. Then the insulin available always less than the capacity. Okay. Okay. The cumulative dose of the insulin delivered. Okay. So clock always start with 0, 0, 0, 0. So cumulative dose is always 0. Start from 0 for the day. So for whole day, like today when I restart, as the patient wake up, it will start from 0. So the first dose will be added. The next dose given on the same day added to the earlier dose. So that you can find the cumulative. You can make sure you don't give more than the maximum per day. You understand or not? It doesn't exceed the maximum. Cannot exceed the maximum. Okay? Then cumulative dose cannot exceed the maximum daily dose. And the status equals to error and display daily dose exceeded. So when the maximum dose, okay, when this goes wrong, error message will be displayed. Clear? When you try to attempt to give more than the maximum dose, error message will be displayed. Okay? So this is how you write the requirement. See, it's all mathematics, but we can read as a requirement. Can or not? Can someone help me to read this one? Who can help me to read this one? This line. Anyone? To show that you understand how to read mathematical requirement or requirement written in mathematical notation. Anyone? Quick. Capacity equals to 100 and safe meaning equals to 6 and safe maximum equals to 14. What's the meaning? Capacity, maximum capacity of insulin available is 100. Okay, but I don't know what is the unit for insulin. Cannot be milliliter, 100 milliliter cannot be too much. Must be something lower than that. Okay. Safe meaning 6. Safe maximum, safe minimum and safe maximum. What is safe minimum, safe maximum? Minimum dosage can be given to a patient, depends on their levels of glucose, different patient different. Or not everyone will be taking the same dosage. So minimum dosage can be given to a patient is 6. Maximum dosage can be given every one dose 14. But maximum for the whole day, I'm not sure. Let's see whether got or not here. Yeah, daily dose, maximum 25. Maximum 25. So minimum dose every time is 4. Maximum every time 14, but for the whole day you can give many times, right? Plus, the cumulative cannot exceed 25. See? All mathematics, but we can come up with the requirements. So these are the requirements. You understand or not? You need to do this assignment next semester. Group 4 to 9. So be prepared. Okay? Okay, group 1 to 3 are doing now. Next week, right? You. Formal method, next week, right? You. Next week. Good luck. Okay. The dosage computation. So now comes all the calculation and operation. Okay. So this is one operation. What is run schema? Who can explain to me? Run schema. This is the operation. First, you have the declaration. What is the name of declaration schema? What is the name of declaration schema? State schema. Then you have all the conditions which must be always true, like validation. That is known as what schema? Predicate. Good. The third one, operation. Operation schema can have as many as you want. Like for example, add product, delete product, update product, 3 operations. Same. Here is run schema and the patient runs. What happened? Okay. So can anyone try to explain one line? This one. These 2 lines. Anyone? What is the meaning of status equals to running versus union? Union status equals to warning. Then insulin available greater than or equals to maximum single dose. So before you can actually induce the before you can induce the glucose, you need to check whether the insulin storage available is more than the dose. If you don't have sufficient insulin, the dose is let's say 4, you only have 3. Can you start inducing? Cannot. You cannot. You have to come up with warning message, ask to restock. You understand? So that's the meaning. Okay. Then you see this one, sugar low was union, sugar okay, union, sugar high. Okay, so this one cumulative dose, okay, daily. Okay, what is the meaning of this line? Who can tell me? This one, comp dose, okay, equals to 0 to dose not equals to 0. So what's the meaning? If the computed insulin, okay, dose is 0, don't deliver any insulin, don't deliver any dose. This is the calculated dose available one. That is 0 means no stock, no insulin in your device. So don't deliver. See, just simple to write long sentence, no more. No need to waste time writing long sentence. Okay, who can explain this line? Because I'm not going to explain every operation. So maybe this operation. Who can explain this one? Computed insulin dose, okay, plus cumulative dose. Cumulative means how much has been given for the whole day, okay, must be greater than maximum daily dose. Equals to alarm, okay, not equals to on. Alarm not equals to on means what? Off. Okay, and status equals to warning, and dose not equals to maximum daily dose minus cumulative dose. So what's the meaning of maximum daily dose minus cumulative dose? Dose not equals to maximum daily dose minus cumulative dose. Who can explain this? Maximum how much of dose you can take in a day minus cumulative how much of dose you have taken. So what does it show you? What does it show you? Again, dose not equals to maximum dose, this is one dose, okay? So, dose plus cumulative dose doesn't exceed the maximum dose. Doesn't exceed the maximum dose. If doesn't exceed the maximum dose, the warning can be closed. But if exceed the maximum dose, you have to, controller need to instruct on the alarm to send the warning. You understand or not? So, this operation to check before you induce if the last dose you are taking for the day doesn't exceed the maximum cumulative dose for the day. You understand or not? So that's the meaning. Clear? So because some patients are very serious, every time glucose level can go so high. But you cannot simply induce. You have the maximum dose to be given. So if after that still high, but you already taken the maximum dose, cannot induce. You need to stop, send the patient to the clinic. Admit. Okay? So cannot simply ask the device to keep giving. No, cannot. So that's the meaning. Understand or not? So run here is not this run. Run is the device operate. Okay? Operate. Clear? Okay? So you have all the others, you can go through yourself. Okay or not? Can you follow or not? More or less you understand what is mathematical notation or not? Interesting, very interesting. For me I like. Okay? Just that. You need to understand all the symbols. You need to know how to write. You need to learn the syntax and semantics, just like programming. If you know the syntax and semantics, I'm very sure you can. Okay? Clear? Okay. So formal specification important or not this semester? Important or not? Yes. How many marks? 8 marks. That's the tips for you today. Okay? 8 marks question, formal specification. Pay attention. Okay? Clear? So see, for those who came for class today, I give you one tip to encourage your attendance for the next class. Okay, you come next class, I give you more tips on the the topics. Okay? So 2 more classes only, 3 more classes left. One for the remaining chapters, and then the other classes are revision, past year. We will try past year questions. Okay? Okay? Please come. I'll try to find some similar past year to go through. Okay? Okay. So last part. Okay, functional requirement. Okay, you have seen, right, requirement written like this. The downtime of the system need to be low. Is this okay to write like that? The downtime of what do you call that system must be as low as possible. Right? The availability, I always see students write, the system must be available all the time. Correct or not? The way you write. Assignment, anyone got write like that? You still have time to submit, right, your assignment. So that's why I'm going to dismiss you already. Your non-functional requirement, if you have written something like this, better go and change. You won't get any marks. If you write, the system should be available all the time. What else? The performance of the system must be high. What is high for you? 1000 transactions per second? 2000 transactions per second? 5000 transactions per second? Everyone can define their own meaning. Correct or not? So that's why you shouldn't write very subjective or very general. You shouldn't have this kind of requirement in your document. SRS shouldn't have. Okay? How to write a specific requirement? A good quality requirement should be measurable. You know what is measurable? When you test functional requirement, at the end you will do a lot of testing. Functional requirement, you test, then you see output similar or not. Pass. Correct or not? Always we test the functions. If the function works as expected, pass. How do you test non-functional requirement? Tell me. How do you test non-functional requirement? You don't test. My students are going through final system testing for FYP this week. Some done, some doing. So how do you test non-functional requirement? How do you test? That's why every requirement need to be tested. So your non-functional requirement also need to be measurable. So when I test, I can say this system is reliable or not reliable. If I cannot test, how can I confirm this is reliable or not reliable? This is portable or not portable? This is secure system or not secure? How do I ensure the quality is achieved or not? Need to be testable, measurable. Remember, measurable. So now you see how to write. Availability. Do not write available all the time anymore. 24/7. Wrong. Do you have any system that available 24 hours in a week without single maintenance? Without any maintenance? Oh no. No. You go and see most of the systems, especially bank system, 12 to 1 a.m. it won't be available. Why? Because it's down for maintenance. So none of the system can work 24 hours. Even though it's a machine or system, it has to have a break. You understand or not? So don't write like that. Okay, wrong. So this is the way we write non-functional requirement, like availability. The system shall be at least 95%. This 95 is not your favorite number or your lucky number. No. You need to calculate. 1 week how many hours? 24 hours. 1 week how many hours? This is daily or what? Weekday. So 1 week. So 24 times 7. How many hours down for maintenance? Calculate times 100. How many percentage downtime? Then you write the uptime. You understand or not? 5% downtime means maximum 5%. So must be at least 95% uptime. You understand or not? So that's how you calculate. Not your favorite number. Okay? So 95% available on weekday between 6 a.m. and midnight Eastern time. At least 99% weekdays between 3 to 5. Wow, very accurate. So because you know why? Certain time transaction is very high. So the availability, maybe they don't do any maintenance during the time. Like evening, too many transaction, too many customers. So they do a lot of, they don't do any maintenance. So they want the uptime to be 99%. During the less customer time, they allow to be maintained. The system allowed to be maintained. So 95%. You understand or not? So they come up with very accurate requirement for quality. Another example, integrity, interoperability. Okay, the chemical tracking system shall be able to import any valid chemical structure from the chemical draw, okay, and Marvin sketch. You know some device, right? You need to submit the sketches of the this chemical, like I remember one of the project I handled before. The structure of the chemical, you have to upload the file. So the upload drawing, the drawing file can be in any format. Your system can accept any format, only to specify what are the format acceptable. So when you upload something other than this, the file is not detected. Okay? It's just like other systems. Certain format is allowable. Right. So this is interoperability. Okay? Go for performance. Authorization of an ATM withdrawal request shall take no more than 2 seconds. Very clear, 2 seconds. If it takes more than 2 seconds, automatically you need to do something on the performance already. You need maintenance. The system is not, the performance requirement is not, achievable. So you need to do something wrong with the server. Maybe too much of data, too slow due to something. You need to find out. You understand or not? Time for maintenance. Okay? Security. You see, with a period of 5 minutes, if you are unsuccessful, bank systems are doing this. So you need to go for 5 minutes break. You know why 5 minutes break? The system will do some validations and verification within that 5 minutes if you are using the system or not. Because you try, nowadays bank systems are doing that, not bad. You try to log on 3 times with invalid password, it will automatically log the whole thing for a few hours or few minutes. You cannot log in within that few minutes. Again, they don't let you to attempt again until they try to do some validations or verification. Okay, then confirm no one is using except you. It will detect the device. Are you using the device that you have used before? Something as a network. It will check the network IP. If you are accessing using the same IP or not. If anything spotted like totally new environment, totally new, it will try to contact you. They will lock the account totally. They don't allow you to log in. This is how the bank system works nowadays. Security. Because too many cybercrime. Too many. This afternoon, after the class, I received a call. Then I am unable to attend because I was driving. Then once I reach home, I attend the call. Then you know what was the reply? The number is not in the service. I just received the call a few minutes ago. The number is not in the service. So sure someone is misusing the number. So thank God I didn't answer. See, a lot of things happening now. Okay? So this is how you write the requirement. Clear? Safety. One more example. The system shall terminate any operation within 1 second if the measured tank pressure, this one chemical, maybe radioactive or maybe any kind of dangerous chemical, when the pressure exceeds 90%, so something going to happen, explosion or whatever. So it has to terminate all the operation within 1 second to save the life. So this kind of requirement known as safety. So students are always going to get confused between safety and security. Security is all about data. Plus your web-based system, your mobile application, nothing to do with safety. Don't tell me when you press the wrong button you get electric shock. Alright. So that is security. Okay? If you want to protect your information, like your account information, your payment data, what kind of any data, important data, protect from leakage. Okay? Protect from access by unauthorized people. That is security, not safety. Safety means the system can harm the user or again harm the environment, then it is safety. So for assignment, class assignment, as I know most of you go for simple mobile application or web-based project. If IoT based, then you need to see first. Okay? So try to remove safety. No safety requirement, most of you. Just use the keyword security. Remember the template for safety and security. No safety, remove. It's irrelevant. Okay, for your project. If your title something like instrument park like just now, ATM, or maybe any other project that you love to like parking system. Parking system can safety can. Because if when you take the card sensor doesn't work, let's say the value drop, that is safety. That is safety. Okay? So any hardware involved, embedded system, safety. Okay? So all those are safety. So no safety, remove safety. Only security, data protection. Okay? Okay. Can you understand how to write non-functional requirement now? Make sure you write correctly in your assignment. Must be measurable. Okay? Okay. quality attribute trade-off. Okay, so what's the meaning of trade-off? Okay, one quality affect the other quality. Can you give me an example? When you try to achieve security, you want to have a very tight security. 1 tier, 2 tier, 3 tier security. Last time just log in with ID and password. Now do you notice bank system, ID, password, then your secure word, right? Secure word, and then image verification. Then sometimes pin send to your phone for verification. First tier is login ID and password, then image verification, then go for pin or something. Then already 3 levels of verification. So these are known as very high security implementation. Alright, so when you do this kind of implementation, right, what happened to the performance? One quality is good, security improve. But what happened to the other quality, like performance, efficiency? Will be improved as well or will drop? Yeah, that is called trade-off. You try to improve one quality, another quality automatically can improve. Positive trade-off. When you try to improve one quality, the other quality affected negatively, drop. Negative impact. Directly proportional, directly proportional. You learn last time in Maths. Okay? So something like that. So when you try to improve like security, look at the performance, negatively impacted. When you try to improve, for example, performance, efficiency, positively impacted. So that's what I mean. Okay? That is known as trade-off. Okay? In exam comes out means you should be able to, I'm not saying it will come out. If come out means how to answer. You should pick 2 different quality to show how they are relational to each other. So when one improves, the other one is affected. So you must pick the correct example. You must pick the correct example like what? Availability and reliability. Availability, reliability. Because if reliability low means availability also will be low. The system won't be available. If performance high means you cannot be focusing on security. So that's how I affect each other. Okay? Okay. Last one. Guideline to write a good requirement document. Okay? So system versus user perspective. I don't know why. Sometimes you won't get confused, when you write the requirement. The first requirement you say the system shall allow the user to do blah blah blah. The second requirement you talk from the point of system. The system shall blah 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 blah. You cannot mix up like that. If you are talking from the user perspective, all must be user perspective. If you are explaining your requirement from system perspective, you must explain all in the system perspective. You cannot mix up both in one document. That's very important. You must have both, but shouldn't mix up all together. Must document nicely. Okay? Example, if the requested chemical is found in the chemical stock room, the system shall display, so system perspective, a list of all containers of the chemical that are currently in the stock room. So this is system perspective. Okay? So no user involved, you see? Okay, system user perspective, this is user perspective. The chemist shall be able to reorder any chemicals he has ordered in the past by retrieving, editing the order details. So user perspective, what user perform on the system? How system responds? System perspective. Clear? Okay, must show that very clearly, but shouldn't mix up both. Okay, must group them, categorize them clearly. Okay, writing style. Okay, you have to make sure your assignment, which you will submit very soon, clarity and concise, clear and concise. The keyword shall, must, okay, shall, should, may, can, all this must be clearly used. Active voice, individual requirement. Don't join more than one requirement into one statement. What is the term for this problem? More than one requirement, join as one requirement. What is the name of this problem? I covered in the same chapter. You have more than one requirement within one statement. Cannot. Like, midterm test, I remember. What the customer should add, remove, or update accessories. Cannot. and they don't minus, they don't give marks. Because amalgamation. You combine more than one requirement in one sentence, one statement, cannot. Not allowed. You should write 3 requirements separately. The system shall allow the customer, not customer, the staff to add accessory. The system shall allow the the staff to remove accessory. The system shall allow the staff to update accessory. Okay? So since midterm, I cut the other 2, I still gave half mark to my students. But remember, you shouldn't combine more than one requirement like this. Not allowed. Every time when you are writing quantity requirement, you must have the quantity attribute. The keyword must be there. You can write performance requirement or reliability requirement without the word reliability, security. You must have the quantity attribute. Must. Okay, practice in such way. Okay? Okay, so all this need to pay attention. Okay, levels of details. You have to make sure it is what up to what level. Sometimes you certain requirement, a certain module, you go so deep. The validation, the sub function, sub-function. Some you only write all the main function. Cannot. You need to determine, okay, I go for level 1 means all the modules level 1. Don't go sub, no need. So detail, no need. Okay? Consistency, yes. Representation technique, yeah. Either you go for natural language means all natural language. If you go like functional requirement, all natural language, all natural language. No one module natural language, one graphical method, one formal method. Okay? But this one I don't think you will make mistake. Okay, you all follow. No ambiguous requirements. Clarity is important. Okay, incompleteness also. Some of the functions totally missing. Because you know what? When you write one module, right, you don't identify all the roles involved in the module. For example, when you say place order, what comes to your mind? Place order means only customer. So you write all the requirements for customer, you ignore the staff or admin, system admin. Try to analyze, see whether any other user involved in each module. Don't miss out some important roles, so you don't have the requirement in your document at all. So incompleteness. Clear? So that's another important point. Okay? Any questions?